Welcome back to another coding session, continuing with Bangalang, our low-level explicit procedural compiled language that we're creating, with the hefty goal that it should be able to run on the CPU and the GPU, distribute workloads across both. And in that vein, we have got something really basic that will distribute work across the CPU now. And I've been trying to understand, what features do we need in a language that will allow us to get closer to that goal of distributing across the GPU. And there's not so much more we need, there's a few more things. One thing I wanted to flesh out was the idea of allocators. I'm just going to do some really basic allocators. We do have a concept of allocators in the language already, although it's very basic. It's just that a procedure definition is basically considered static. So I think of static as anything that's embedded in the executable. Okay, let's disable the test for now. I just wanted to run this. So right now we have all these procedures here. So because it's embedded in the executable, I consider it static. And all of these variables here, I also consider them static, but they're they're like literals from the language. They're stored like this. And now I want to be able to explicitly say, like these, for example, are they're like static variables, you could think. So I want to be able to explicitly say that they are static. And this is the way that I want to do it. This is how I want to apply an allocator to something. So now it's an I32, and this @static means that it uses the static allocator. That's kind of the syntax that I want to try. I just sort of made it up on my own. I don't think there's any other language that does a syntax like this. So let's see how well it works. I'm not sure how well it's going to work, but we're going to try it. But actually, before we get to that, I think I just want to improve our concept of staticness. Like in our type checking, if I search for static, I kind of want to think what does this really mean? And how can we improve it? Maybe it is better to do it in the context of making this work. So we have a goal in mind already. So we have this idea of static and we want to expand it so that it can work for not just procedures, but variables. So this is a static procedure. And the other thing, okay, so the other thing actually, yeah, this is why I wanted to just cut these off for now. The first thing is that there's kind of like a default allocator, If we don't supply an allocator when we declare something, then it has a default. And like I was saying, procedures they're by default static. That's the idea. And anything else is by default stack allocated. So those are our two allocators that we kind of have at the moment. So I kind of want to make that a bit more explicit in the compiler that the default for these is static. So I wanted to make a bit of a helper function, which is getAllocator. And allocators are just strings right now. Maybe we'll get more elaborate later, but they're just like a name for now. So you need to pass in an identifier node to see whether that identifier refers to what is the allocator associated with it. So if So the allocator is actually on the type node, I want to say. So we get the type, and if that has an allocator, then we return it. But this identifier might be a member of a struct. That's the only thing I can think of really that it would be a member of. And that struct might have an allocator, or it should have an allocator, but the member should not. It will just, there's no point in having an allocator for a member of a struct. So if this is a member, but this is member could mean that it's a member of a what am I trying to say? A module. We could be, where's an example? Could be like this, right? This is a member of this module, but modules don't have allocators. That doesn't make sense for a module to have an allocator. So if we say that the type of the first child, which would be the thing that it's a member of, is a module. So it's a member but not a member of a module. And we didn't have an allocator on the member, which makes sense. Then we get the allocator of the, we get the allocator of the thing that it's a member of. That makes sense to me. Otherwise, we return the default allocator. So if the type node is a procedure, like I said, that defaults to static, and everything else defaults to stack. That's the idea, right? So now let's look for anything where we have stack and see whether this get allocator really is a better fit. So this here is this is when we're dealing with procedures, and because we didn't really have the concept that an empty it had a default allocator, we had to explicitly say it was static. But we don't have to do that anymore, so we can cut that out. This is saying, this part here is saying we cannot redefine a type, but a quirk of it, so that's why it's saying, so it's saying like if this is already a defined identifier, but we are specifying a type, because at this point in the type checking, we have not inferred any types, it would just be a type explicitly supplied by the user, then that's invalid. But there's a quirk where static procedures, we kind of can't get around that, like the static procedure is already in the identifiers, and we're going to, when we get here, so we just like to get around that, we just say if it's not static procedure, pass in the node. So we already have like this is procedure statement. And I'm gonna rename that to static because that's really what we want to say. And say is, but also have an is static procedure. So this is where we start with the left-hand node, I guess. So that just take the left-hand side off everything. And So we're saying all this stuff, but we also want to say, and if we get the allocator of the node, it should be static. So now this is basically if node is an assignment and the left-hand side node is a static procedure. So that simplifies that a lot. Okay, so now we have this is static procedure. And why the hell did I want that again? So these hard-coded procedures, we don't need to explicitly say they're static anymore because it's a default. So we can cut those out. And where were we? This here is checking if it's a static procedure. Oh no, it's not node. This is the node, right? Like so. So check if it's a static procedure. And I think there's another one, oops, that's just like that. Where was it? Here? Yeah, that's checking if it's a static procedure. So again, we get the identifier node. I guess this get type, we already use it there, so we don't really need to get the type before. Okay. Cool. All right. Let's review anywhere else we have static. So this one, yeah, this is the method we did before. This is also what we did before. If it's a static allocator, yep. So I think that's all good. What happens if we run that? Failed to generate primary. And the node is get time of day, which is a member of a module, but it doesn't seem to be, well, so it should be going into here. Because we have this, so we should have actually changed this to is static procedure. We're still here. So what is the node? Does it still get time of day? So it doesn't think that it's a static procedure. So what is its children? This child is a module. I don't know what its type is. I guess we don't get the type node. The child type node. This module. So why is it not going into here then? Oh, because it is a member. It can be a static procedure if it's a member of a module. Okay. So if it's a member and I guess we need to get the type. So if it's a member of a module, if it's a member and but a member of something that's not a module, we return false. If it doesn't have a type, we return false. If the type is procedure, so that's kind of type stuff. And then we check the actual allocator. Okay, a bit more sophisticated now. Let's see if that works. Okay, we get to generation. So func. Func is in the standard library, I believe. Yeah, here it is. So this is, and this is the one we're looking at, I think, stack params. Yeah. So this func should be stack based because it's a parameter. So I guess that's an exception to the rule. If this is declared as a parameter, then it is by default stack based. So I think what we can do is when we are type checking, I guess it'd be type checking an assignment. No. Yeah, I think so. Yeah, here it is. I think. Yeah, so this is when we're setting up all our identifiers for within the procedure. I think we just want to take this, we need to get the type of the parameter node and give it an allocator of stack. I think force it to be stack. Let's see how that goes. Okay, that seems happy. Great. We have a rogue window. I need to close these. I was working at the cafe this morning playing around with this, and my battery went dead really fast, and I was like, why is it going dead so fast? And it's because I had two of these windows in the background. And because the purpose of this example program is to do lots of work, it was like using up a lot of battery. So I need to be careful of that. Okay, so I think we've got that aspect done. Now we can get back to making some static variables, something new. So this is a bit more, this is a grammar change. So if we go to our grammar, I think I'm going to put it on left-hand side expression. I don't think I want it to be possible anywhere where there's a type primary. Type primary. See, type primaries can exist in struct types and procedure types, but we don't want, procedure parameters, procedure return types, struct members. None of those things should be able to declare an allocator. It doesn't make sense. So instead, I'll make it just an optional extra thing here. I'll just call it identifier. So yeah, so in our expression we can have a regular left-hand side primary. Optionally we can have colon type primary. And then even more optionally, we can specify this, this guy. Actually, you could define this or this. Currently it is saying you have to define this before you define this, but that's okay for now. But I think later we might want to make it so that you could just define an allocator but not the type, because the type could be inferred. But let's not worry about that right now. Keep things simple. So we need an extra token, the at token, and a tokenization. Sweet Jesus, this is horrible. Sorry, I'm gonna have to take care of this because it hurts my brain. Closing square bracket. I just love to have If you've watched any of my videos, you know that I just love to have everything nice and alphabetically ordered. Colon equals goes here, exclamation goes just after, OP, MOP, asterisk is right at the start, backslash goes just after, percent, period, pipe plus comma, LM, comma, hat, HI, dash greater than. Okay, and the new one is at, which is this guy. Cool. So that should mean that tokenization works. Let's get rid of some of these files because we're not using them right now. So parsing, what do we need to work on for parsing? It's parsing a primary, what did we change? Left-hand side expression, that's right. Here we go. So this is the optional type info. We have to be careful with this because if we're modifying the type node some more, so if we find an at, we need this to be after. Because I want to modify this type node a bit more, I want to put an allocator on it, and we need to do that before we append to the children. So I guess we get the next token, which is an identifier, and take the value of it. That's basically it, right? Cool. I think that's parsing done. We don't venture too much into parsing these days. Mostly type checking and generation is much beefier areas. Okay, so now we can specify that something is static. What does that mean? What do we need to do with that? I think in type checking, when we're type checking an assignment, so if we come into here, this means we're declaring a new thing. So I think I want to go if get allocator of the left-hand side node is static. I want to put a few rules in here. So I want do we have like an integer? That's close. I want to limit it. I want to make this static stuff very limited. So you can only do it for integer types. Because we're not going to allow, and we're also not going to allow any expressions. You know, you can't do like this. This can just be a simple integer on this side. That's all. Because that makes it very simple for us to insert it into the executable. We could expand on it later, but this is all we're doing for now. So we do an error and we can say something like cannot allocate non-integer type blah with allocator blah. Yeah, something like that. That'll do. Whoa, what the hell did I just do? Where are we? So So now I can put the allocator in. Oh, we still have this really old school style. Huh. I can't be bothered fixing that at the moment. Cannot allocate non-integer type. So this is the type. So now if I was to say like F32, types F32 and I32 not compatible at line 65. What? Ah, okay. I guess that's where it gets used. Yeah. So it seems like it was happy to create that. So does it not know that the allocator is static? Well, it's on a built-in type, and we do the type resolution, resolve types, and that blows away the whole type node, which will get rid of our allocator. So what happens is, like, initially when we come through, this is just considered an identifier, or it needs to be like confirmed, I guess you could say, as a type. It needs to match up to a type that is a defined type, and that's what this does. But the way it does it is to basically override the whole node. So let's save the allocator from the node, and then is it just if? No, I guess we never keep the allocator from our predefined thing, right? We just always use it, I think. I don't know. I guess we'll find out if this is wrong. And this is the other place where we do it. Okay, so maybe that will... we need to put a colon. Maybe get the right error now. Cannot allocate non-integer type F32 with allocator static. Perfect. So now if I go I32, and is this where? Here we go. So now I want to do another check. If the length of dot children equals 1, or dot children 2 dot type does not equal number. So basically this is saying if we are not explicitly using a number here, this will be a multiply node. This is a number node. It needs to be just a number. So now it's kind of like must explicitly, Jesus, is this explicitly, must explicitly assign integer literal. When using allocator blah. I think that should be fine. So that should throw a hissy fit. Ooh. There. So that throws a hissy fit at line 11. Yes, because we can't do times 2. Great. Okay. But if we look at our assembly, we still see this is the declaration of those static things. This means they're not static. You know, we're allocating on the stack. So when we generate an assignment, first thing is we don't want to allocate. So if it'll become clear why I'm doing the if in here right now, but if I get allocator of the, I guess it's the left-hand side node, equals static well, actually it's like if it's not static, then we do the allocation. That should get rid of this line. This line we need to remove and replace with a line down here. So how do we do that? So what is this line actually? This is the assignment. So it's the expression, generate expression. So I guess it's generating a primary. Or is it just that we don't generate the assignment at all? Yeah, maybe we just don't generate the assignment at all. Then we wouldn't actually need to do this. Yeah, let's just skip the assignment. So generate assignment. No, where was it? It's generate statements, isn't it? It was right near the top. Here we go. So instead of skipping just static procedures, let's skip all static assignments. So we have is static procedure assignment. What about is static assignment statement? The static procedure. So then it's just like if get allocator. It's pretty much that. So that should skip the assignment. It doesn't have an S. So we'll probably get an error now, probably crash. Oh, we crashed during compilation, it looks like, because nothing got spat out. Because it should be the left-hand side mode, which is this one. Okay, we get a bunch of errors. Yeah, and we don't see glfw init as the first thing. So we don't generate any code up here, which is correct. But we do need to generate so this is where we generate all of our static variables. So we need like a generate static vars, which I guess takes the file, the context, what else does it need? I guess we'll just use the main procedure statements. I think I need to get into the habit of using slices more. So this would be statements, which is a slice of AST nodes. Instead of doing, like sometimes I do need to do this, but like here, for example, I don't think I do. We don't need this generated procedure names thing. Okay, and for statement, in statements, basically we say if is a static assignment statement, but we don't want and not static procedure. So So probably not the most efficient condition in the world, but gets the message across. Assignment statements, but not procedures. Anything else? What's wrong with this? Oh, nothing. Great. So each of those, we do something like this. I guess we have an LHS node in the assignment. Statement.children0 will be the LHS, and the RHS will be the second. So the value of the left-hand side is the name. Oh, we need to change this. And then this will be the value. So that would be the right-hand side. Is that also just the right-hand side value? Right-hand side node should be just a number. So yeah, I think that is. Okay. But this DB, we need to change. So let's make, I guess I'll call it a define size. So this is going to be like a switch kind of guy, you know, something like this. And it's like switching on size 1, 2, 4, and 8 are the possible values. Oh, usually I put unsupported define size. That's the kind of message I know we put. So this will be db define byte, or define bytes, define word, I guess. I don't actually know, but I think that's what it is. Define double word, define quad word. So now up here in our static thing, we'll sort of say to define size. And that's byte size of get type left-hand side, I guess. Should do. To define size, %s. That should be it. That should generate our static variables. So if we run that again, we should still get, oh, missing return statement. So just return an empty string. We should get our errors still. Yeah, a bunch of errors. But now if we look at the bottom, here we go. Defined as dd, that's right, for a 32-bit integer. So that looks good. Looks good to me. So the problem probably is that we never actually refer to these. So now in generation, when we go to here it is. So a static procedure, maybe we just can say get allocator static, so just anything static. Now we're referring to it, but it's still not working. But I have a feeling like if we go see these other numbers that I have stored down the bottom, see they're stored the same way, but they're floats, and they have square brackets around them. So I think they need to be treated like memory. So probably we need to say like is static procedure then do that. Otherwise, do that. Treat it like memory. Okay. Oh, we have rogue windows. I can also tell that because my laptop's working hard and the FPS goes low. Okay. So I think that's static. Yeah, I think that's static variables sorted like that. Very nice. So that's our static allocator. So now let's try another allocator, one more allocator I want to do, which is the heap allocator, which I think in comparison is going to be quite a lot easier. Let's go my heap int is an i32 at heap. Stop trying to be smarter than me. Okay, so this is already something a bit weird. Is like when I'm allocating from the heap, I'm always going to get a pointer back, right? That's what you get back from the heap, is a pointer to the allocated memory. That's kind of how it works. We need to do that because we need to keep track of that pointer. If we don't save the pointer anywhere, then we don't know where the memory is and we can't use it. So really, I think I'm just going to enforce that you have to use a pointer type when you're allocating on the heap. So let's expand our type checking. Where do we do it? So here, yeah. So if the allocator is heap, then we want to say if the type node the type does not equal reference, which means pointer, then that's a problem. Cannot allocate non-reference type with allocator. So now we should get an error. Cannot allocate non-reference type i32 with allocator heap. Great. So let's fix that. Okay, that's fixed. But if we look at the assembly, we can see that it's just done a regular stack-based allocation and initialized it to 0. So we need to override that. And it should be in our assignment. When we're doing an assignment, see here's where we allocate it on the stack. So let's make that allocate stack, deallocate stack, and then see if we can find it again. Here we go. So I guess we need to get the allocator. I guess we could have done a switch here. That's okay. Get the allocator for the left-hand side node. And if allocator equals heap, we do one thing. If allocator equals stack, we do another thing, which is what we were already doing. And in both cases, we're going to do this. I'll explain that in a minute. And if we got some sort of other allocator, that's an error. We should probably prevent that from happening. Like at the moment, you could just put at anything, and it would just, well, I guess it would crash on this assert. Failed to generate assignment. So here I want to do basically like allocate heap. Yeah. Yeah, we'll get to this afterwards. So let's make an allocate heap procedure. So the reason, like if we go to mmap, this is a procedure that allocates memory. And we can see first thing it does is allocate something on the stack, and the last thing it does is copy the result. So because, like I said, we need the pointer. So the pointer is what's going to be allocated on the stack. Okay, so this allocate is basically a stack allocation. So we go allocate stack, and we want a pointer, so it's an address size like that. So that should take care of this top line, allocating for the pointer. So that's like assigning the pointer back to the top of the stack where we just allocated. So this will assign, because the result of the syscall is in racks, so it'll assign it the pointer back to our newly allocated space. This is our syscall number 9. This is the address. I think I remember all these, which we put 0, because you can specify an address that you want to allocate or something. I don't actually get it. So this is where we're going to actually use the size. This is the amount to allocate. Now we have like prot and flags that we'll have to grab. I think it's file descriptor and offset, which are -1 and 0, I believe. Need to look these up. So if we go to, yeah, here it is. So this is where we do mmap. So it's like 0, the amount we want to allocate, and then this is prot and flags -1, 0. So that's prot. This is flags. And then -1 and 0 we have done. Okay, so that should be a syscall that allocates memory and returns the pointer back. And because we have done a stack allocation in our context, where is it? That means that we can say where our variable is on the stack. This is where our pointer is on the stack, basically. And it also means that we can still use this condition to tell whether this is an existing variable or not. So let's run that. So now our first assignment looks like, oh no, this is mmap. Let's go to the top. Here we go. This is our first assignment. I should probably rename these to heap. Like so. Run that again. Okay. A bunch of these don't look good actually. Because they all have these variables that they're not actually using, except for that one. So they're not even format lines actually. Okay, so let's run that. Okay, that looks better. So that pretty much looks like what we expect. We're allocating 8. This is the only thing we substitute in actually. We're allocating 8 bytes. which actually is wrong because it's an I32 that we want to allocate space for. So it should be only 4 bytes. And then we have this. So now at the end, we're initializing it because we haven't explicitly put a value here, which is bad because we're taking our pointer and then just clearing it out. So there's a couple of issues. So this size is wrong. If we go to allocate heap here, so what do we actually want the type of? This is byte size of left-hand side type node, which is a pointer. I guess we just want its first child, because this is the reference. It's a reference to, and the first child of it will be what it's referencing. So that should be the I32. So if we make that change, now we see we're allocating 4 bytes. Great. Now we need to cut this out. So I think that's down here actually. Yeah, because we only have 1 child, we don't have a right-hand side in this assignment. We are nullifying, so maybe that only makes sense for stack allocators. I think we might need to move the allocator out. So we've run that again. Now that looks good. Okay. So we should be able to use that. So if we dereference and assign 42 and then do something like standard lib exit, I have to cast I64. Then we should exit with code 42. Okay. So that worked. We assigned some memory. Now we are yeah, it's a bit weird that we do this actually, because we could have just gone like, I think that's the same. Oh, well, no, this is a pointer. The value at RSP is a pointer. So now this is the pointer, and now we treat that like memory. Yeah, okay, that's correct. Okay, and then this is the exit. I'm pretty happy with that. Yeah, we have some basic allocators. Heap allocator, static allocator, and the default allocator is a stack allocator. Like you could go add stack, but it's kind of pointless. Like if I take this out, it should still work fine. It's just a bit pointless to explicitly say that it's stack allocated. Great. Okay, we have a little bit of time left. Maybe we should finally separate the files, because these files are getting so big. Like this type checking file is 1300 lines long. It's very big. So, okay. Let's make some directories. Generation. Move this in here. Oh dear. Moving that file just like almost crashed my IDE. Hopefully it didn't crash the recording. So let's go like procedures. And let's just have the procedure stuff. So like generate procedures. like so. Generate procedure, that's it. That's all this is in charge of, this file. Undeclared name AST node. Okay, I'm not sure why that is, but let's take those procedures out of here now. Generate procedure. Yeah, I'm not sure why it doesn't know about AST nodes. Is it a folder thing? Because it's this folder? Because they're all in the same package, so I thought that would take care of it. This is the first time I've used folders in Odin. Maybe it is a folder thing. If I import ... is that a thing? Main can't find gen context. Undeclared name gen context. Ah, because it's in here. So if I import generation, /generation, path does not exist. Oh. Okay, I think I'm going to do a bit more research into this. Where's my Odin conversation? Does it know what I'm talking about? I don't even know how to say it. So maybe that's because I need to say generation and generation. And import main. /main. But now if I go to the main and I say that I'm importing generation, does it know what I'm talking about? I think it does. Path does not exist. Okay, that's interesting. So maybe this AST needs to be its own package then. Oh, I thought that was going to work. Path does not exist. So maybe it needs to be in its own folder. ./AST, is it? Come on. So now that doesn't know about file info. So source, let's put source in here. and call that source. Oh, file info is not. I thought file info would be in source. Where is it actually? Is it in parsing? Or tokenization? Or there it is. Let's put it in here and include format. Oh. But doesn't source have file info in it? Package source, folder source. We're importing source. Why don't we see the file info? Does this file have errors in it? It doesn't seem to. I think it's all good. It doesn't depend on anything else. Main imports generation. That imports AST, which should give it the AST node. And I don't know if it's not just because of that error. Yeah, I really don't know how this stuff works. I think I need to actually like properly investigate this a bit more before we do this. Shit, I should have done a whip. I should have done a whip commit. So this procedures just had these two procedures here. That's right, generation is where I want to put them. So generate program, I think it was in here. So we just get rid of this. It seems to have a really good think about this. Okay, source, let's bring that up here. And anywhere that I did this weird package stuff, let's fix it up. Source. We can leave the file info in here. I think that's better. Does that work? Don't need to do these imports anymore. We need format. Okay. All right, let's just leave it like that. I'll figure out how this Odin stuff works with imports. I'm pretty happy that we've got allocators working. I don't know if I actually said why we need that, but like at some point, you know, currently in our current program, this is how we allocate on the GPU. What I want to be able to do is say, like, how many vertexes do we have? I guess it's vertex count. Should be able to just do this. That's what I want to be able to do. So instead of this. So that's another allocator. You can think of it as GPU. Cool. All right. Enough for today. Thanks for stopping by. Have a good one. Ciao for now.